All right, 4.3, reciprocal trigonometric ratios. And before we dive into the concept of a reciprocal trigonometric ratio, we're just going to quickly review the trig ratios, the primary trig ratios. So you have primary trig ratios in your knowledge bank. They are reflected by or represented by Toa. Now, we didn't talk about them so much in terms of opposite, hypotenuse, and adjacent in our previous lesson. Instead, we were working inside, and try not to take up too much space because we are going to have a couple of notes underneath this, but instead we're working in a unit circle, and we were given some angle, theta, whatever it is. This one's easy because it's in the first quadrant. And let's say it has the point, I don't know, 5, 7. Goes through the point 5, 7. Okay, well, that tells us the x value and the y value. So we now, if we have a right angle triangle here, we know that this length is 5, this length is 7, and all we would need to do is find the hypotenuse. Okay, so how did we do that? We found that using the Pythagorean theorem. We simply said 5 squared plus 7 squared is r squared. So we have x, y, and r. 5 squared is 25. 7 squared is 49. That equals r squared. So we get r squared is 74, which makes r the square root of 74. Wherever possible, we're going to use exact values. So I'm going to leave this as a radical 74. And now I have the value of x is 5, y is 7, and r is radical 74. Well, it turns out that the opposite over hypotenuse, in this case it's easy to see because we're in quadrant 1, but I have 7 over radical 74 for sine. So the sine of my angle theta is y over r, which in this case is 7 over radical 74. The cosine of angle theta is x over r, which for this angle is 5 over radical 74. And the tangent of angle theta is y over x, which, by the way, is the same as saying sine over cosine, and it's also the same as saying opposite over adjacent. So y over x, we end up with 7 over 5. And you can see that that's the same as sine over cosine. Because sine and cosine have the same denominator, it would just be 7 over 5. That would be the reduction of sine of theta over cosine of theta. At any rate, these now are the 3 primary trigonometric ratios for this angle that I've drawn here in quadrant 1. And you can do that for any angle around the unit circle. You can even do it for multiples of each angle and all sorts of stuff. And when you are working with special angles, those are the angles that you memorized within your unit circle for the quiz, then it becomes even easier because you already know what these values are automatically. Now, this circle is not a unit circle. I know that because the 0.57 could never be on the unit circle. This has a radius of radical 74, which is bigger than 8 but less than 9. So it's clearly not a unit circle. A unit circle has a radius of 1. Now, taking that, diving into a reciprocal trigonometric ratio. There are 3 primary trig ratios. There are 3 reciprocal trig ratios, which are called secondary trig ratios. Before we do that, you need, do you have any little space along the right-hand side here?
No. Yeah,
if you do, that's fine. If not, just put this note here. But, or I guess we could just put it here anyway. Reciprocal. Do you know what a reciprocal is?
Wait, okay.
It's like the number, but like flip.
Yeah, it's when you flip a fractional number, okay? Opposite tends to deal with positive and negative. Those are opposites. Positive 4 is opposite of negative 4. They're not reciprocals, though. Okay, the textbook definition of a reciprocal: 2 expressions whose product is 1. That means if you were to multiply those two expressions together, it would equal 1. And if you can do that, then they're reciprocals. It's much easier if you just see a couple of examples. Example, 4 and, do you know the reciprocal of 4?
1/4.
1/4. Another example, what about, I don't know, 3x over 2y? What's the reciprocal? 2y over 3x. Now, you don't need to write this part. I'm going to erase it after I write it. But look at what happens when you multiply 4 times 1/4. 4/4 is 1 whole. See that? Two expressions whose product is 1. Two expressions whose product is 1. We can do the same thing here. 3x over 2y times 2y over 3x equals 6xy, top times top, bottom times bottom, 6xy. Well, that equals 1. Okay? So again, if you want to write that as a helpful reminder, you may. You can make up any of your own as long as they are reciprocals. So what's a reciprocal trigonometric ratio then? Well, all that means is that you're going to take the primary trigonometric ratios and you're going to flip them around. You're going to take the reciprocal of each, but they're going to have a different name. So let's write this. We've got our secondary, and then in brackets you can write reciprocal. Reciprocal trigonometric ratios. Okay. First one that we have is called the Cosecant. That's spelled wrong. Cosecant ratio. Okay. This is the reciprocal of the sine ratio. Okay, I'm going to write things in words and in symbols. So what does that mean? Well, the cosecant ratio is symbolized by or denoted CSC of theta. Remember, you always take the ratio of an angle within a right angle triangle. Okay. The cosecant of this is the reciprocal of sine theta, which is 1/sine theta. If you don't have space to work down, you're going to write 2 more, then go ahead and find a way to just make it into columns. Either way, you're going to have 3 of them. The next one is called the secant ratio. This is the reciprocal of the cosine ratio. It's denoted SEC of theta, and it is, since it's the reciprocal of the cosine, it's 1/the cosine of theta. The last one that we have is the cotangent ratio. That's the reciprocal of the tangent ratio. So every primary trigonometric ratio has a reciprocal. It's denoted cot of theta, COT theta, and the cotangent of theta is 1/the tan of theta. So you don't necessarily need to write what I'm going to do next. It's in our lesson. Actually, I'm not even going to write it because it's in our lesson. But you can see that each primary trig ratio has a reciprocal secondary trig ratio. And one way to remember which goes with which, tangent and cotangent is really easy to remember. They go together. Okay, they are reciprocals of one another. Sine and cosecant are reciprocals. And then cosine and secant are reciprocals.
Well, I'm confused now.
One thing that can help you remember is that in each pair, there is one ratio that has the prefix co in it. Okay? So for example, cosine is not going to go with cosecant because they both have a co in it.
Oh.
Okay? Tangent and cotangent, that's really easy to remember. And then there's only 2 other options. Its sine goes with cosecant because sine needs a co to go with it. And then cosine goes with secant because there's already a co in cosine.
Wait, so the one
Okay,
would be the other one?
It's just a helpful way to remember what goes with what and what is each other's reciprocal. This is how you write reciprocals. Okay, it is also true that sine of theta is 1 over the cosecant of theta, and that the cosine of theta is 1 over the secant of theta, and it is also true that the tangent of theta is 1 over the cotangent of theta. Okay? If this is true, this is true. Okay, so we're going to summarize our findings in this chart that is there for you in the investigation on page 11. If you want to, you can just take a little second and go like this and call these your primary trig ratios. And that makes these your secondary or reciprocal ratios. Doesn't matter which word you use. And basically we're going to find the values. We're going to find the sine ratio for all of our special angles. And this can come straight from your unit circle, or if you have it memorized, that's even better. So if you want to, I mean, by the time you're done this unit, you should be able to just kind of visualize a lot of these things automatically from the unit circle just by drawing a little diagram like that. But who can give me the sine of 0 degrees? So here's an angle of 0 degrees.
1,
What is the y coordinate?
0.
It's 0. The y coordinate is 0. Good.
Wait, why is it y coordinate, not x coordinate?
Because it's the sine of theta, which corresponds to the y value. Do your practice problems. And okay, you have a table that looks like this on page 11 for your investigation. You can see how the primary trigonometric ratios are here, and they are paired with their reciprocal secondary trigonometric ratios. So you have a primary, a secondary, primary, secondary, primary, secondary. And what we're going to do is fill in the exact values of the sine ratio for the special angles that we've memorized within quadrant 1. Okay, so we'll start with the sine of theta when theta is 0. So we're looking for the sine of 0 degrees. Again, you should have these things memorized, and you will have these things memorized by the end of this unit, or at least to be able to just draw a quick circle and reference things. So we're looking for the sine of 0 degrees. That's the y coordinate of the point made by the angle, a 0 degree angle. So it's 1, 0 in the unit circle, and the y coordinate then is 0 for the sine. While we're at it, why don't we put the cosine in there? And why don't we put the tangent in there? The tangent is 0 over 1, sine over cosine, so that's 0. Okay? Now, for our secondary trig ratio,
Just be the opposite.
it's not the opposite, the reciprocal. Okay?
1 over 4. Same thing.
So if the sine of 0 is 0, what is the cosecant of the angle 0? What is the reciprocal of the number 0?
1.
0.
1.
0.
1.
Okay? What is the reciprocal of 1? 1 over 1, if I flip that, I get 1 over 1. I just get 1. Now over here in tan world, tan we have sine over cosine. So it was 0 over 1, which reduced to 0. But now we're going to have the reciprocal, which is going to be 1 over 0, which is undefined. Just to do better, there is no reciprocal of 0 because you can't have anything over 0. So this one is actually undefined as well. So if you drew the function cosecant of theta, if you graphed it using technology, you'd find that there is no, the function does not cross at the line theta equals 0. It's not defined there. It doesn't have a value. Okay, carrying on. Exact value of the sine of theta when theta is 30 degrees. So if you're looking at your unit circle, you've got a 30, a 45, and a 60. You're looking for the y coordinate of this point.
1/2.
That's the y-coordinate?
Yeah.
Okay. Then the cosine is the x-coordinate of that point on your unit circle. What is it?
Radical 3 over 2.
Radical 3 over 2. And the tangent?
I think it was 1 over radical.
Yeah, 1 over radical 3. So now we can do our secondary trig ratios. The cosecant is the reciprocal of the sine. Sine is 1/2, so the reciprocal of that is 2. Secant, the reciprocal of cosine, 2 over radical 3. Cotangent is the reciprocal of tangent. 1 over radical 3 becomes radical 3 over 1. It's just radical 3. All right, let's carry on working a little more quickly. The special angles, the sine of 45.
1 over radical 2.
Good, same as the cosine. And then the tangent is 1. Let's take the reciprocal of all of those. You get radical 2, and 1. And then for 60, 60 is kind of easy. The rest of the chart you can do just by looking at the rest of the chart, because you know that the sine of 60 is equal to the cosine of 30, right? The sine, the y value here, is equal to the x value up here.
It's flipped, right?
No.
Not flipped.
Okay, radical 3 over 2. That makes this 1/2. That makes this, again, if it's x over y, now it's y over x. So it was here 1 over radical 3, so this one is radical 3 over 1.
That's what I meant. Like the x and y's are switched. Sorry, not flipped. Switched.
Okay. The cosecant of theta is the reciprocal of sine theta, so we're just going to take that fraction and take the reciprocal, flip it. Okay, and for cosine to change into secant is the reciprocal, so that's 2. 1 over 2, the reciprocal is 2. And here we have 1 over radical 3. 90 degree, coming up here, we've got the point 0, 1. So the sine value is 1, cosine value is 0, which gives us a tan of 1 over 0, which is undefined. Then we have a cosecant of theta, which is the reciprocal of 1, which is just 1. Secant at 90 degrees is the reciprocal of 0, which is undefined. And here it's a little bit harder to go from an undefined to something else. So you're best off just kind of looking at this and analyzing what's happening here. If tangent is sine over cosine, then cotangent is cosine over sine. So it's 0 over 1, which is 0. So now you have a chart that contains the primary and secondary trigonometric ratios, the exact values for all of the special angles in the first quadrant. This is a very valuable chart. Do you need to memorize it? No, because if you memorize the blue columns, you're good. Okay, and really, you only need to memorize the first few boxes of the blue columns, and you'd be able to fill in this whole chart. Same way you filled in your unit circle. Okay? All right, well, what if we're not dealing with a unit circle? What if we're just dealing with a random triangle, and we want to determine the primary and reciprocal trigonometric ratios in any triangle? That's what we get in example 1. So reciprocal trigonometric ratios in any triangle. We're given a right angle triangle, and we're given the side lengths. It's a 3, 4, 5 right triangle. And we're asked to determine the 6 trigonometric ratios for angle A, and then the 6 trigonometric ratios for angle B. Are they going to be the exact same? Or are they going to be different?
I'm not gonna say anything.
They're going to be different, okay? Because remember, it's opposite, hypotenuse, and adjacent. The hypotenuse will always be 5. But for B, 4 is opposite and 3 is adjacent. Whereas for A, 3 is opposite and 4 is adjacent. Okay, so they are going to be different. They're going to all involve the same numbers, but they are going to be different. I'm going to just do it for angle A, and then you can do it for angle B on your own time. All I need to remember is my primary trigonometric ratios. Sine of A is op over hyp. The cosine of A is adjacent over hypotenuse. The tangent of A is, I can think of this a couple different ways. I can think of it as sine over cosine, or I can think of it as opposite over adjacent. And now I just fill in what I know. I know that the sine of A is from A's perspective, opposite over hypotenuse, 3 over 5. Cosine of A is adjacent over hypotenuse, that's 4 over 5. Tangent of A is opposite over adjacent, that's 3 over 4. Primary trig ratio is done. Okay, that was your practice problems from yesterday in a nutshell. Now, how do I get the reciprocal trigonometric ratios? I just flip these things. I could write all my steps again. I could write that this is hyp over op, okay? And then write 5 over 3. But if I'm getting good at this, which you are, then I can see that it's just the reciprocal of 4 over 5 is 5/4. And cotangent of A is the reciprocal of 3/4, which is 4/3. No, you do not need to reduce it or simplify to a decimal or anything like that. That's not the answer. That's not the way to do it. Leave it as exact answers, okay? In later applications, you'll be using these values and you will need exact answers. So leave them like that. Sine B, cosine B, tan B, you do the exact same thing, but from the perspective of B. And then cosecant B, secant B, and cotangent of B, you would do the exact same thing, except you'd be taking the reciprocal of the values that you got for using angle B. All right, so we now know how to determine trigonometric ratios for different angles, and for any triangle, really. You can determine all of the trigonometric ratios, primary and secondary. You can also, from those ratios now, see here the ratios are given. This ratio, the cosecant of A is 8, secant of B is 5 over 2, the cotangent of C is 5 over 16. We have the ratios. We can now determine the angle as well. And this is similar to what you've done in the past. There's just one more added step. The added step is that I'm dealing with a secondary trigonometric ratio. Normally you'd get something like the sine of A is 4 over 5. And then what would you do? You would take the inverse sine of both sides to get the value of A. Okay? That works because you have a sine and an inverse sine button on your calculator. Second function sine is second inverse sine. Okay? Now, do you have a cosecant or a inverse cosecant button on your calculator?
No, sir.
You do not. So please get out your calculator. All it means is that before we can put this in our calculator, we need to convert it to use its reciprocal primary ratio. So if the cosecant of A is 8, what's the reciprocal ratio of a cosecant ratio? What's the ratio though? So it's not going to be a cosecant ratio. If I take the reciprocal of both sides, right? So, yeah, sine of A is now I've taken the reciprocal of this side. If you don't trust me, let's just do this for a second. I'll add another step for the first one. The reciprocal of cosecant of A is 1 over cosecant of A. The reciprocal of 8 is 1 over 8. 1 over cosecant of A is sine of A. That's by definition, because sine and cosecant are reciprocal ratios. So now I can use my calculator because I can take the inverse sine of both sides, take the inverse sine of 1 over 8, and I will get that the angle measure for A is approximately 7 what's? 7 degrees. If you got a really small decimal, it means that your, if you got like 0 point whatever, it means your calculator is in radian mode instead of degree mode. You need to hit reset or place your calculator in degree mode through the settings. All right, so there I showed a whole bunch of extra steps just to make sure you trusted me. We're not going to do that anymore. We're going to do this a little more quickly. What's the reciprocal ratio for secant?
2/5.
What's the reciprocal ratio for secant? Cosine.
Oh.
So the cosine of b and the reciprocal of 5/2? 2/5. We've taken the reciprocal of both sides. Now I can put the inverse cosine of 2/5 in the calculator. And I'll get?
60.
Okay, we have agreement. 66 what's? Degrees. Last one, cotangent. What's the reciprocal ratio for the cotangent ratio?
Tangent.
The tangent ratio. The reciprocal of 5/16.
72 degrees.
16/5. Take the inverse tan. Take the inverse tan this time of both sides.
72.
And you get approximately, if we work on our rounding skills, 73 degrees.
Dude.
I'm ahead of the game for once, and he just changes the
Work on those.
In example 3, we are doing something similar, but this time we are picturing it inside of a unit circle. We have to determine two angles. This is already written for you in your book, probably.
Oh, yeah.
Yeah.
Two
Oh,
angles
I-
between 0 and 360 that have a cosecant of -2. Okay? Well, let's work on a solution here. We know that the cosecant of the angle that we're looking for is -2. Now remember, just like before, we can find one of these angles using our calculator, and then we're going to have to use a property of our trig ratios in order to find the second angle, okay? But what do we know so far? We simply know that the cosecant of theta is -2. So what do I need to do in order to put this in my calculator and figure out what that angle actually is?
Do sine.
I need to take the reciprocal of both sides. So the reciprocal of cosecant is sine. Sine of theta, the reciprocal of -2? -1/2. Thank you very much. Now, I'm going to think about this without a calculator for a second. I'm here in my unit circle, and I have a sine ratio of -1/2. Well, if I think about the reference angle in the first quadrant that has a sine value of 1/2, it's 30 degrees. Okay? So this has coordinates radical 3/2, 1/2. The sine value is 1/2 because the y coordinate at this point is 1/2. So I actually know that for, and I'll write this, since sine of 30 degrees equals 1/2, the reference angle is 30 degrees. Now, what does reference angle mean? Here's a reminder. Reference angle means that basically I've now created 4 different angles, 4 different points, all 30 degrees. 30 degrees from the x-axis.
Do I have to write that?
Okay, so all of these, my reference angles now are 30 degrees. So I've created a few possibilities here, and I'm looking for the place where sine is -1/2. Well, my sine value in quadrant 1 is +1/2. It's my y coordinate. So all I need to do is flip these guys vertically. So I'm actually looking for this one right here. This point will give me a y coordinate of -1/2, and this point right here will do that. So what are we looking for? What did we find? I'm going to go again from my initial arm. Okay, I'm going to try to ignore all the rest of the stuff in my diagram right now. My first angle that I come across between 0 and 360 that has a sine value of -1/2 is right here. It's 180 plus 30. Okay, so let's write that. First of all, we figured out where is sine ratio negative? Sine ratio is negative in Q3,
Huh.
and Q4.
And Q4. We were both right.
Like always.
Okay, so I'm looking for reflections of my reference angle, reflections of 30 degrees in each of those quadrants. Okay, so from Q3, we get 180 degrees plus 30 degrees, which is 210 degrees. Okay, that's our first solution. And then from Q4, how do I find that one?
360.
Yeah, good job. 360 degrees minus 30 degrees, which equals 330 degrees. So these are our two angles that are in between 0 and 360 that have a sine of -1/2, which means that they also have a cosecant of -2. Okay? So these are our two angles. We could write that in a final statement. Therefore, two angles between 0 degrees and 360 degrees with cosecant of -2 are 210 degrees and 330 degrees. Okay, concept walking through that very quickly again. We were given a secondary trigonometric ratio and told to find the two angles for which that's true. We can't do that as is. We flipped it to its reciprocal primary trigonometric ratio. From there, we just related what we already know from the unit circle, things we already have memorized. We know that the sine of 30 is 1/2. That gives us our reference angle of 30 degrees, which we then reflected into quadrants 3 and 4 because that's where sine is negative and we're looking for where sine is negative. And then we just did that. We added 180 and 30 to get our first angle. And we took 360 minus 30 to get our second angle. Another key point that this brings up that we'll talk about later is that your secondary trigonometric ratios are actually positive and negative in the exact same quadrants as their reciprocal primary trigonometric ratios. So the cast system, CAST, okay, that applies to the reciprocal secondary trigonometric ratios as well, right? This would be secant, all cosecant, and cotangent would be the only positives there. Good. Your practice problems are from page 246, and they are numbers 1 through 8.
1 over 1.